Hi, welcome to my channel. So today in this video, I will share the review about this 20 amps buck converter. While here's the Excel 4015, which was capable of doing 5 amps max, this 300 watts buck converter can handle 20 amps max. So you can say that it's the father of this Excel 4015. Father or mother, I'm not sure about the gender. So I will show you. First of all, let's talk about its input voltage. Its input voltage range is from 6 volt to 40 volt DC max, and at the output it will give you 1.2 volts to 38 volts or something else. And I already told you about the amps, 20 amps max it can handle. So let's start. Wirings are already done. I will power it up with my 1400 watts power supply, which I modded to 14 volts. And I will also show you by driving some loads that how this buck converter handles the voltage and current much efficiently. Also, it can be used as a battery charger. So let's start. So it's connected to the power supply now. I have no regards for safety. Don't be like that. Otherwise, it will be your last day on earth. Unlike XL 4015 buck converter, in which when output short the output terminals, it goes into the current setting mode, then you can adjust the output current desired which you want. But in this module, you can't simply short the output terminals because it's capable of doing 20 amps. So you can't just short the output terminal and set the, you always have to first connect the load, then you will adjust the output current with the help of this potentiometer. This is the most important point to be noted. So let's set the output voltage. I'm going to drive the 4 volt LED at maximum amps at about 14 to 15 or more than that. So I will adjust the output voltage to 4 volts or 3.95. As you can see that it's set on 13.81. So I am going into the anti-clockwise direction. The voltage is decreasing. In the clockwise, it should increase. 3.91. 3.99. It's okay now. As I already told you, you can't just short the output terminals to set the current. You always have to connect the load first. So I'm going to drive this LED. It's sending 30 watts LED, which operates on 4 volts and maximum 8 amps. But I will overdrive this on more amps like 14 to 15 or more than that. So let's first mount it on a copper heatsink to dissipate as much heat as possible to cool the LED down, because more amps mean more heat. So all set now. LED is tightly filmed on the heatsink. So let's turn on the power supply. It's super bright. Let's measure the output amps. Here's the clamp meter. DC amps. Oh man, 18.3 amps at 4 volts. More than 64 watts of power. Let's further increase the amperes. Okay, that's the limit. Current is not increasing. Further, to increase the current, I have to increase the voltage. You can see that it's now at 20 amps. Smoke is rising from the LED. Let's turn it off. And the heatsink is pretty hot now. It's not too hot. This heatsink of MOSFET is not too hot. So let's decrease the current. As we have seen that it can easily go to 20 amps. Hats off to this LED which is handling 20 amps while it's only rated for 8 amps max. So you can see that you can say that it's a tiny beast. So now only half ampere is flowing through this LED. So at 15 to 20 amps, you have to add the fan after 5 to 10 minutes because this heat sink would get super hot, near to 60 to 70 degrees Celsius. Okay. This converter can also be used as a battery charger, very efficient. But I will show that in another video. So if you have any questions regarding this converter, you can ask me in the comment section. Don't forget to like, share and subscribe to my channel. Stay tuned for the next video.